All right, the learning target this unit has been probabilities and the concepts of combinations versus permutations, which is what quizzes 1 and 2 covered. The unit test is coming up shortly. Please use this to help make sure you're fully prepared for it. Number 1 asks, what is the probability 2 juniors are randomly chosen to lead the team out with replacement? So the idea here is with replacement, we will have 14, and we need to divide by the total. We've got 25 players total. If we replace them, both numbers, numerator and denominator, will remain the same. So we ultimately want to multiply those two fractions by each other. And we get 14 out of 25, 14 out of 25 as a fraction. That is what something's asking for, which has more accuracy. The probability is 196 out of 625. And as a decimal, that comes out to 0.3136. So if you're asked to round to nearest like 10th of a percent, 31.4%. So that's A. B. All right. What is the probability a junior is randomly chosen as offensive player of the week and another junior is randomly chosen as defensive player of the week without replacement? So without replacement. So the first probability is going to stay the same, 14 out of 25. Again, because 6 plus 14 plus 5 is 25, like I explained on A. Our second probability, though, if a junior's picked, we're down to 13. Means the overall total is down to 24. So our second fraction we would be multiplying now. There's now only 13 juniors out of 24 possible players. We do our multiplying there. 14 times 13. We got 182 over 600 exactly. So 182 over 600. If we divide those, the decimal value is approximately 0.303, which means as a percent, we would write 30.3%, a percent rounded to the nearest tenth. Okay. Moving on. So let's take a look at 2A here. Survey concludes that 50% of students drank Pepsi, 25% drank Mountain Dew, and 10% drank both. Both. So we got this overlap. Why is drinking Pepsi or Mountain Dew not mutually exclusive? What is the probability a student drank Pepsi or Mountain Dew? That both tells us it is not mutually exclusive. We've got 50 in the Pepsi group. And then we've got, and then 25% in the Mountain Dew group. And then we've got this overlap of 10%. So what is the probability a student drank Pepsi or Mountain Dew? If my answer is as a percentage, it would be, all right, add the two, but subtract. Don't double count the people that are in both groups. So 50 plus 25, 75 minus 10, 65%. Most likely on Khan Academy, you want to put your answer in as a decimal, 0.65. Okay. On to 2B here. Why is the preference for chocolate or vanilla mutually exclusive? What is the probability a random chosen person prefers chocolate or vanilla based on that data over there? So chocolate. 33 people preferred chocolate, right there. Vanilla. 11 people prefer vanilla, right there. And the last category is no preference, not both. Keyword, no, both. Whereas the keyword over in the first part of number 2 was both. Okay. So our probability is a little bit simpler there. We've got 33 and 11. So that word or. So it could be this group or that group. Over 50. And actually, in the mental math there, that's 44 over 50. To turn that into a decimal, double it. So that would be altogether 0.88 or 88%.